Hi, welcome to this episode of The Mentored Engineer. In this video, I want to review a video by Fixtronic where they take a piece of tube and add some cuts to it and fold it into a right angle joint. Okay, let's get to it. So this video is entitled Secret Profile Pipe, Why Do Welders Not Speak About It? And it is super cool. I've never seen anything like this, and I just want to give a review. Overall, I think it's a great joint. I just want to make the point that it is not a structural joint, and I intend to show you how that is. Okay, so let's go to the video and highlight some of the critical points of why this is not a structural joint. So as you can see from this video, there's a lot of time-lapse stuff. We're doing a lot of work to it. We have a lot of scribing to do, as we're showing here. We're going to scribe and then cut out pieces. So this is a very labor-intensive joint. You don't have to make that many. It's probably okay. Here we're scribing. We got to make a cut. We have to make an angled cut with a grinder, which is very difficult. And we'll just go through a couple of little sections of the video here. All right, we've made 2 cuts here. And we're gonna make some more. So when we're grinding the rounded corner here, as you see in this steel frame, you can see that there are some notches here from grinding the other part. You got one here, one up here, one up here. And eventually you're going to have one way down in here, and you can see another one here. And that's just the ones that we can see from this angle. It's not a really good angle for seeing those. But every time you have one of those, it is a stress concentration in your tube. And it's just not helpful to the joint. Rule of thumb about engineering is if it looks like a crack, it's going to behave like a crack. So that crack can be either something that was designed in, or it can be something that you do because your process involves a lot of grinding. All right, moving on. So right here, we're starting to fit up the corner, and he's going to pound this into position. One of the things about pounding it in position is you don't know how much force you're inducing on this. So your joint may already have a bunch of stress in it. And if it has a lot of stress in it, it's either going to be strain relieved quite early and stretch a little bit, or it might actually crack, especially if you have the ends of the grinding wheel already in that location, which you probably do in the right point right here. All right. You're also going to have problems if you can't get the angle to work up just right. If you're a little bit short, you have to grind a little bit more off the edge, but if you aren't, if you have a gap, there's not much you can do other than fill that in with weld, and that could be a decent gap. So your joints are somewhat unpredictable. All right, in the next part of the video here, he is putting in welds on the ends here. Now you'll notice here, especially on this outside one, it is a butt weld. You have 2 plates butting up against each other, and then you're just putting weld on top, and it's not really getting hot enough to get down in there. He's welding with a stick weld, and he's just tapping and tapping, tapping, and just to fill it in with weld. So it's not getting very hot, so there's very poor penetration to begin with. With both of these welds that he's going to do being butt welds and poor penetration, it's just not a structural joint. All right, so now we're just going to pretty it up. And I want to stop the video right here and just comment a little bit more about why this is not a structural joint. We've already seen the butt weld. We've already seen the grinder edge in there. But from a purely physics standpoint, this is just not a good joint. So let's just say we have the joint in front of us, and it's coming out like this, and we just try to push that together or pull it apart. Doesn't make a difference. All right, in that case, we would see compression on the front edge here and here as we push them together, And we'd see tension back here going around this surface and back over here. Now the reason that this is not a good design is you aren't balancing your forces well enough. All right, so coming down this surface here, my compression stress needs to go somewhere. And it needs to go through to this, all the way into the sides of this plate and eventually to the back. And it only has the ability to do that on the top and bottom here. It doesn't have the ability to do it anywhere else in that section. So what you're going to end up with is a giant hot spot if you look in FEA at this spot right here, and then conversely on the bottom. All right, same thing when you go this way. You have all this material and then you only have the top and bottom edges to take that load. So that's building on that other hot spot. On the outside, you have the same thing. You need to get this stress from here around this corner, and the only way that this angled part is supported is on the top and bottom. So you're going to have high stresses all the way around on this right here and relatively calm in the middle of it. So it's just not going to do anything. You can put a doubler plate on that joint if you like, but it probably won't have much success. All right, so the last thing I want to say closing out this video is that the most expensive tool in a welder's toolbox is the grinder. We want to keep him away from using the grinder as much as possible because it's just a time sucker. So if you're doing high production on something like this, don't include this. This is a time-consuming joint. It looks pretty, and it's great, but it's not a structural joint. It's not for high production. Well, thank you for watching this episode of The Mentored Engineer.